Hello everyone, this is Adish. I'm a grade 10 student from Mumbai. So today's problem is chef and numbers. The difficulty level of this problem is simple because it's rated only 1396 and you only need to know the very basics of one-dimensional dynamic programming in order to understand my solution. So in this problem we are basically given chef who has n dishes of different types arranged in a row. A1 through AN is the array of the types of the dishes. The ith dish has a type AI. Now chef wants to choose as many dishes as possible from the given list while satisfying two conditions. He can choose only one type of dish and no two chosen dishes should be adjacent to each other. The first condition basically means that he has to fix the type of dish and then he has to apply the second condition, which is he has to keep choosing the maximum number of dishes possible such that no two chosen dishes are adjacent to each other and they are only of one type. So for example, if n is 9 and the types of the dishes are 1s and 2s, then chef can choose, let's say that chef chooses a type 1 dish, then he can choose the first one, the fourth one, the sixth one and the eighth one, or he can choose the first one, the fourth one, the seventh one and the ninth one. Either ways, he has chosen 4 dishes. If he chooses the type 2 dish, he can choose only 1 and 2 dishes or 1 and 2 dishes, and that's why he should go for type 1, which is the type of the dish he should choose so that the maximum number of dishes, which is 4, is maximized. So basically we need to compute this quantity of the optimal type of dish for t independent test cases where the number of test cases can be up to 1000. Now the constraints on n, ai and t are very important. So we are guaranteed that the sum of n doesn't exceed 10 to the power of 4, which means that we can consider only one test case where n is 10 to the power of 4, and we can use the fact that the values of ai are up to 1000 only, which means that if we use an n into ai algorithm, that will work in 10 to the power of 4 into 10 cube, which is 10 to the power of 7 operations, and that will easily fit in 1 second. So that's why the algorithm has a time complexity of n into ai, and it's actually the sum of n into ai, where the sum of n is up to 10 to the power of 4 and ai is up to 1000. So let's understand how we can come up with such an algorithm. So let's consider an example first. Let's consider the 3 examples. So in the first example, I think we have this is one example obviously where the answer is 1, because type 1 we need to print the type of the dish and we need to print the smallest such type of the dish if there are multiple dishes which give the same maximum number of dishes. So in this case 1 is optimal because 1 gives 2 dishes and even 2 gives 2 dishes. However, we need to print the smallest dish, which will be 1. In the second example, there's only one type of dish, which is 1, so we'll print 1. And in the next test case, if you choose dish 1, then you can pick 2 of them. If you choose dish 2, then you can pick 1, 2 and 3 of them. If you choose dish 3 or dish 4, you can pick only one of them. That's why it's optimal to pick dish 2, and that's the output, because you can pick 3 of dish 2 and only 2 or 1s of the other dishes. So in general, the key idea is that you should iterate through all possible values of the type of dish. There are up to 1000 possible values only, because ai is up to 1000 only, because ai represents the type of the dish. So you should iterate through all possible types of dishes. Once you have fixed the first condition, which is the type of the dish, we can use one-dimensional dynamic programming to maximize the number of dishes which you pick, satisfying the second condition, which is that no two chosen dishes should be adjacent to each other. So now I'll be explaining how we can use the 1D DP in order to maximize the number of dishes, given that you have fixed the type of dish and no two adjacent dishes should be adjacent to each other. So the key idea for the one-dimensional DP is that obviously since you are using one-dimensional DP, the value of the DP will be dpj is max number of dishes, which we can pick, such that we are considering only the array from indices 1 to j. We are considering only a1 to aj, and I is a fixed variable. I is the type of the dish which we are picking, we are picking. Now I is obviously the type of the dish, which can be up to the value of 10 power of 3. So we iterate through all I. For each I going from 1 to 10 power of 3, we will compute this dp of g, and since g represents the array, the index of the array, where j can go up to n, this means that basically j belongs to 1 comma n, and there are at most n possible values of j, so there are at most n dp states which you need to compute, and that's why if we are able to compute this in O of n, the term complexity will be O of n into 1000, and that's just O of n into max ai. So let's understand how we can compute this dp state. So the key idea for computing the dp state is that if you're considering some particular value of j, which is between 1 and n, if first let's start off with the base case, because that's a simpler thing to understand. So dp of 1 will be 1 if a of 1 is equal to I and 0 otherwise, because we know that if the first element is equal to I, it's obviously optimal to pick that dish, to pick the first element, pick the first dish, and hence the number of dishes which you'll pick will be 1. And if the first element is not the desired dish, then obviously if it's not equal to I, then you can't pick it, because you can only pick dishes of type I, and that's why the answer will be 0 for dp of 1. And that's just the base case. There's only one base case. Now for the recurrence, which will be computed for every dp of j, where j goes from j is 2 to n, for every such value of j, we will basically, there are two options. First of all, if a of j is not equal to I, then we know that we can't do anything. We can't pick the ith dish. We can't pick the jth dish. That's why dp of j minus 1. So dp of j will be equal to dp of j minus 1 if you can't pick the ith dish, if you can't pick the jth dish. However, if you can pick the jth dish, then there are two cases. The first case is in which you pick it. So in that case, if you pick it, it will be 1 plus dp of j minus 2, because you know that you can't pick the j minus 1 dish. So the reason behind the first, so it's maximum of two quantities. The first quantity is when you pick it, and the second quantity is when you don't pick it. So if we pick the jth dish, if we pick aj, which is equal to I, this means that we can't pick aj minus 1, and hence we go with dp of j minus 2, because that's the one before aj minus 1. However, if we choose not to pick aj, if we don't pick aj, then we can basically go to j minus 1. We can pick j minus 1, so we just take the value of dp j minus 1 as the dp value for the maximum number of dishes which you are picking, and this is basically the recurrence. So this is a one line base case, and then there's a loop which goes from 2 till n, and in the loop we just check these two conditional statements and compute the value of dpj accordingly. And in the end, obviously the maximum dp of j for all j going from 1 to n will be the maximum number of dishes which you can pick for the when you consider only dish I. So for dish I, the max number we can pick, is given by is equal to max of dpj, where j goes from 1 to n. And once we compute this max dpj, we can compare it to the global maximum. So we are obviously maintaining a global maximum value of the dpj, and the global maximum value of the number of dishes which we pick. Initially it's 0, and whenever we get a non-zero value, we will just replace it. So whenever we get a new value, let's see that this quantity is greater than the global max, then we know that I will be the correct dish. So we will set the dish value to be I, and we'll update the global max to be this quantity, and that's basically the full solution. In the end, we'll just print the dish which corresponds to the global max. So now I'll just show you the code which implements the same idea. So in the code, first I taken the value of t, the number of test cases. While the number of test cases are greater than 0, while the test cases are not equal to 0, we will decrease t by 1. We will take in the value of n. We will take in the array A. We will compute max dishes, which is the global maximum, and position basically represents the optimal dish to take, and position is actually the final answer. For all I, consider the ith dish only, the ith dish, and we compute this dp array. Initially the mx represents the max dpj, so we will just update the mx with all the dp values. So if a of 1 is equal to I, dp of 1 will be equal to 1, and we will obviously initialize mx to be equal to dp of 1. Then for all j going from 2 to n, so this is the base case, and the recurrence is basically if aj is equal to I, dp of j will be the maximum of dp of j minus 1, comma dp of j minus 2 plus 1. Otherwise dp of j is equal to dp of j minus 1. And note that by default all the values are initialized to 0, so you don't need to worry about negative numbers and all. So that's why the max will always be positive, and it's fine to put the mx to be 0 and max dishes to be 0. And if mx is greater than max dishes, then we know that the optimal position, the optimal dish is I. Otherwise, and we update the global maximum. If mx is equal to max dishes, then it's optimal to go with the smallest dish, number, and this smallest dish number is actually pause, because we are iterating in increasing order of the dishes, over the dishes in increasing order. That's why since we are iterating across the dishes going from 1 to 1000, that's why we are going in increasing order. So whichever dish we have considered before as the optimal dish, that will correspond to the smallest dish number, and hence we'll update the dish number only if we get better max dishes, and max dishes is computed using this dynamic programming. And in the end we'll just print pause with an endl, because pause represents the optimal position. And now I'll just submit this code to see that it gets accepted. So the code which I showed you and submitted actually failed because of a bug over here. So this is a common mistake, to not update the maximum value. You need to put this statement over here. As you can see in this wrong answer code which I just submitted, the statement was missing of updating the maximum value of max dpj. That's why this code gives a wrong answer. So this is an example of a common error which you can make. However, once you update the error and once you update this statement, this important statement, and if you insert that over here, then you can verify that this code gets accepted. So I hope you like this problem and my solution. If you have any doubt in any part of the solution, do leave them in the comments down below. And if you like this video, don't forget to give it a thumbs up. Thank you.